So in this video, I'm going to talk about strategy and how to represent normal form games from an extensive form game. So you can convert an extensive form game into a normal form game. So let's look at it. So first, what do we mean by strategy? A strategy, let's use a different color here. Okay. So a strategy is a complete contingent plan for a player in the game. So a strategy is a complete contingent plan for a player in the game. So by complete contingent plan, I mean a full specification of a player's behavior, which describes the actions that the player would take at each of his possible decision points. Keep in mind that because information sets represent places in the game at which players make decisions, a player's strategy describes what he will do at each of his information sets. So it's possible that in a game, even if a particular information set for a player has not reached, the player must specify what he is going to do at that particular information set. So let's try to look at it by first considering a simple extensive form game. So let's say we are looking at a game where you have two players. So the initial node belongs to player one. And let's say player one has two strategies: charge a high price or a low price. And then player two gets to play the game in the second stage. So contingent on what player one has done in the first stage, player two will get to play in the second stage. And that decides at which node player two is going to play. So let's say player two also has two strategies to play the game: charge a high price or low price. And same here, high price or low price. So I'm using prime, H prime and L prime, to denote that it's at a different node, but the strategy is the same here. And you will see the relevance of it while writing the strategy profile for each player here. And then let's say the game ends with payoffs of 2 to player 1, 3 to player 2, and 1 and 2. And here, let's say 4 and 3. And here, let's say 0 and 2. All right. So these are, think of them as profits. So now we need to write down the strategy set for both players. So first, let's look at the strategy set for player one. So strategy of player one. So it's a set. So player one has only one. Player one has only one information set, and that's here, right? This is the information set that belongs to player one. So player one has two actions to play the game: either choose high price or low price. So that's the strategy set for player one, high and low. Next, let's look at the strategy set for player two. So now, as you can see, player two has two information sets, one here and one here. So player two has to specify what he is going to do at every information set. So basically, let's say player two is here on the top, decision node here. So in this case, let's say player two says that he will choose to charge a high price, so H, but then he also has to tell what he's going to do here, the bottom node, the other information set he has. So that's what we mean by complete contingent plan. So even though you're here at the top node, but you have to tell me what you're going to do here if it were reached, right? So let's say player two says, if he were here at the bottom node, he'll choose H prime, high price. So that's one strategy, particular strategy for player two. But that's not all. So player two at the top node plays, let's say, high price, then he can always choose low price here at the bottom node, right? So you can say H and L prime, that's another strategy. And similarly, you can write down the other two. So if player two chooses low price at the top decision node, so L, and says he'll choose high price at the bottom node, so H prime, and then L at the top and L prime at the bottom node. So that completes your strategy set for player two. So here in this game, player two has 4 strategies to play the game, and player one has only 1 strategy to play the game. All right. So just to make sure that you understand this concept, how to write down the strategies, sets for each player playing the game, let's consider another game. So let's look at this game now. So let's say the game has, okay. So we have 2 players. So player one gets to play the game first at the initial node and has 2 strategies to play the game. Either he can move down or he can move forward. If he moves down, the game ends with a payoff of 3 to player one and 2 to player two. But if he moves forward, then the game progresses to the second stage where player two gets to play the game again. And here player two has 2 strategies as well. He can move down, and if he moves down, the game ends with a payoff of 4 to player one and 5 to player two. Okay. And if he moves forward, that's the other strategy player two has, then the game reaches the third stage where player one gets to play the game again. And he can move down, D prime, or move forward, F prime. And either way, the game will end. So here, let's say payoffs are 5 and 2, 5 to player one, 2 to player two. And here, it's, let's say, 1 and 6, 1 to player one and 6 to player two. So this is another extensive form game where you have 3 stages in the game. And so let's look at the information set first. So player one has 2 information sets, one here and one over here, right? Those are the places where the player one has to make decisions. And player two had just 1 information set here, right? So next task is to write down the strategy, set for player one. So player one has to specify what he's going to do at the initial node, as well as what he's going to do at the last node, the decision set, decision node here at this point, the stage 3. So let's say player one says he's going to choose down. at the initial node, and then he say he's going to move down at the last node as well. So that's one strategy for player one. Or he can move down at the initial node, but here at the last node, he says he's going to move forward. So that's another strategy. And player one can always move forward at the initial node, so forward. And then he says at the last node, he's going to move down. Or he can move forward and forward again. So there are 4 strategies for player one to play the game. And here for player two, the strategy would be, the strategies are just 2 of them: move down and move forward. All right. So that's how you write down the strategy sets for all players in a game. And this is an extensive form representation. Keep in mind that we are not solving the game yet. We'll look at the solution concepts later in this course, and then you will know how to solve these kind of games. So next, let's look at another representation of game, and it's called the normal form representation of the game, or strategic form representation of the game. So let's look at normal form game now. So let's see. So we have normal form or strategic form. Let's strategic form again. So since you're going to use the strategies, and that will basically, that's why we call it a strategic form game. So here what we do is we represent the game using a matrix where the rows and columns are basically the strategies available to the players. And the dimension of the matrix, that is the number of rows and number of columns, will tell you how many strategies each player has. So let's convert the extensive forms that game that we have covered before into a normal form or a strategic form game. So let me write down the game again. So let's consider the most basic game we had, where there are 2 forms, right? Form 1 has 2 strategies: charge high price or charge low price. And then form 2 has to play the game. And in this case, form 2 also has, can charge high price or low price. The same game we discussed before. All right. So this is a perfect information game. There is no asymmetry here, no dash line connecting the 2 information sets for player 2. So we already know the strategy spaces, right? So let me just first write down some payoffs. So let's say this is 3 to player 1, 2 to player 2, 4 and 1, 0 and 5. And here it's, let's say 2 and 2, right? They're just random numbers I'm throwing in here. All right, so that's your game. So player 1 has 2 strategies, H and L, charge high price or low price. And player 2 has 4 strategies, as I described before. So either choose high price at both nodes, that's 1, high price at the top node, and low price at the bottom node, low price at the top node, and high price at the top node, bottom node. And low price at both nodes. Okay, so these are the 4 strategies. So now we know that player 1 has 2 strategies and player 2 has 4 strategies. Therefore, the matrix will have a 2x4 dimension. So let's look at it. It will have a 2x4 dimension where player 2 has 4 strategies. So let's add a little bit more space here. Okay. So player 1 has 2 strategies. So we can here, and then 1, 2. Let's add one here. All right, so this is player 1. Rows belong to player 1. Columns belong to player 2. So player 1 has 2 strategies. So high price and low price. So rows belong to player 1 and columns belong to player 2. So player 2 has H prime, one strategy, H L prime, the other strategy, then L H prime, and then L L prime. So those are the 4 columns we have. So they belong to player 2. And next we can fill in each cell with the payoffs that you have in the extensive form game. So let's look at how we do it. So say we have, so let's say player 1 chooses to charge high price, this one here, and then player 2 chooses high price as well at the top node and high price at the bottom node as well, right? So what happens? The relevant path is this. You go like this, and then this, and this. But since this one is out of the, the path that we are considering here, so player 1 chooses high price and player 2 chooses high price, they will end up with a payoff of 3 to player 1 and 2 to player 2. And this payoff is irrelevant here because player 1 never chooses, is not choosing L here, and therefore this node will not be reached. But this is just what player 2 would have done had this node been reached, right? So contingency plan, basically. So this is immaterial here. So you just write 3 and 2. Now player 1 chooses, next let's consider player 1 choosing high price, and then player 2 is choosing low price, right? So then this is the relevant path. So you go like this, and then you're going like this. So you'll end up with a payoff of 4 to player 1, 1 to player 2. And it doesn't matter what he's doing here because this is not relevant here right now because player 1 hasn't chosen L. All right. So now if player 1 chooses high price and player 2 chooses, L and H, so L and H prime. So L is the relevant one. So you still have 4 and 1. And if player 2 is choosing L prime, still L, this one is relevant. So 4 and 1. All right. And if player 2 chooses low price, then this becomes the relevant node, and this is the irrelevant node, right? So player 1 chooses low price, and player 2 chooses, let's say, high price on the top node and high price on the bottom node, H prime. So this is the relevant path. So the payoff would be 0 to player 1, 5 to player 2. And next, player 2 chooses H and L prime, then this becomes the relevant node. So payoffs are 2 and 2. And if player 2 is choosing L and H prime, then this becomes the relevant node, 0 and 5. And if player 2 is choosing L prime, then this becomes relevant, so 2 and 2. So this is the matrix representation of the game. We also call it normal form or strategic form game, right? So let's take another example to make sure that you understand how to convert an extensive form game into a normal form game. So let's go back to the other example that we had. So let's look at okay, so now we are going to look at the other game we had. So player one at the initial node can move down. Game ends with a payoff of 3 and 2. Again, the payoffs may not match from the previous one, but doesn't matter. And because we're just trying to represent the game. And here, player two, so this is 1, this is 2. Player 2 gets to play the game, moves down, moves forward. Here, game ends with 4 and 5, let's say. And if he moves forward, in the third stage of the game, player 1 gets to play the game again, and he can end the game by moving down D prime, and payoffs of 0 and 4, let's say, or he can move forward and end the game with the payoff of 5 to player 1 and 2 to player 2. Okay, so let's convert this game into the normal form or strategic form game. So first thing is the strategy set. So for player 1, we have strategy set D. He can move down at the initial node. So this is one node, and this is another node for player 1. So he can move down D prime, or he can move down at the initial node and forward at the last node. Or he can move forward at the initial node and move down at the last node, and move forward at both nodes. So player 1 has 4 strategies, and player 2 had just one node here, the information set. So player 2 had just 2 strategies, move down or move forward. So this game will have a 4x2 dimension, 4 rows and 2 columns. So let's do that. So all right, so here we have player 1, player 2. So player 1 has 4 strategies: D, D prime, D, F prime, F, D prime, and F, F prime. And player 2 has 2 strategies: move down or move forward. All right, so next let's fill in the payoffs here. So if player 1 moves down, game ends, right? It doesn't matter what player 2 does and what player 1 does on in the third stage. It's immaterial. So the payoffs would be 3 to player 1, 2 to player 2. And if player moves down and player 2 moves forward, it's again immaterial because game ends with payoffs of 3 and 2. If player move down, game ends. It doesn't matter what player 1 does at the last stage, which is here, or player 2, because they don't get to play the game. So payoffs are going to be 3-2, 3-2. Same. But if player 1 moves forward in the first stage like this, then player 2 gets to play the game. And if he moves down, game ends, right? It doesn't matter what player 1 does at the third stage of the game because he doesn't get to play the game there. So the payoff would be 4 to player 1, 5 to player 2. So this becomes the relevant path, right? And if player 2 moves forward in the second stage here, then the players, once third node becomes active, and then the strategy becomes relevant. So FD prime, meaning player 1 moves forward, player 2 moves forward, and player 1 moves down, right? So then the payoff would be 0 and 4, 0 to player 1, 4 to player 2. And if player, so next we have to look at player 1 moving forward and player 2 moving down, game ends. So payoff would be 4 and 5. F prime is not in play here. And if player 2 moves forward and player 1 moves forward at the third node, then this is the relevant one, right? So then 5 and 2. So that's your normal form representation of this extensive form game here. Okay, so next let's consider another game where we have imperfect information. So we can go back to the basic game we had, high-low, and we can use that game, a version of that game to see how you can convert that extensive form game into normal form game, right? So let's go back to that game, and we had, so let's do it here. Player 1 or firm 1, you can say, has 2 strategies, high price, low price, and then player 2 gets to play the game, but player 2 doesn't know what player 1 had chosen in the first stage, right? So you can denote that by a dashed line. That means player 2 doesn't know whether player 1 had chosen high or low price. And player 2 has its own strategies, H and L. And here we don't have to distinguish between by using F prime anymore, because player 2 doesn't know whether he has the bottom node or top node. So he just chooses high price or low price. So we don't have to use the dashed lines anymore. So the payoffs are 3 and 2, 1 and 4, and here 2 and 2 and 1 and 3, let's say. All right, so strategy space, right? Let's look at player 1 strategy. It has just one node here, information set, so high and low. And player 2 has just one information set, that's 1, because he doesn't know where he is right now, right? So just high and low. So it's a 2-by-2 game. So here we have a 2-by-2 game. So player 1 and 2, high, low, and high and low. So if player 1 chooses high and player 2 chooses high, then the payoffs are 3 to player 1, 2 to player 2. If player 1 chooses high, player 2 chooses low. So you're moving like this and this. So 1 and 4. And if player 1 chooses low and player 2 chooses high, so you're going like this, 2 and 2. And if player 1 chooses low and player 2 chooses low as well, then you have 1 and 3. So that's how you represent this extensive form game with asymmetric information.